Hello and welcome to this video about Python for data handling. In this video lecture you will learn about the Python list, which is a Python native data storage abstraction. The list provides Python users with a data storage solution which is versatile, extendable, updatable, changeable, general, and a one for almost all situations solution for most types of data storage. Some Python users even consider the lists or modified lists to be the solution for every or any and all data storage situations. The list is a very common data storage tool, both as a standalone object or as an object inside other objects. The Python list is a very useful tool to know for data handling purposes. Now we're going to talk some in detail about the Python list data type. And for data science, data analysis, and machine learning purposes, the Python list data type is the most useful, versatile, and general data storage type available. The list data type is a container for items or objects that are ordered, changeable, and allows duplicate items or values. In practice, this means that with a Python list, we can update, delete, remove, or add objects to the list, or even add copies of existing objects in a list to the same or another list after the list has been created. This is a very useful property of the list, and the list can also accept any type of Python objects, so a list can contain integers, strings, arbitrary user-created objects, tuples, sets, other lists, or whatever object you want to have in the list at the same time. The object types don't matter to the list object. And this means that the Python list is so general that the stored objects don't need to be of the same type. And this property of the Python list has consequences as compared to lists in some other languages. And this consequently means that when you use lists in practice, in applications, you must control whatever object your program put into the list, and both control the objects themselves and the knowledge of the object types. Or if you don't have that knowledge or that level of control, you must check what type of object you get from the list when you ask for the object, or an object at a position in the list. Because when you ask a Python list for its contents, you will receive the contents. And sometimes it may be an integer, and sometimes it may be a string, and sometimes it may be a float, or an arbitrary user-created object. And we can say that many users of Python lists for applications with uncontrolled data input or content recommend the type and value checking both when the object is added to the list and when the object is read or extracted from the list. Another way to obtain similar control levels is to recreate all input objects to a predefined coded object type before adding the new object to the list. There are, for example, advanced instances where the object type is unknown, not defined by Python, or not defined at all, or in some extreme cases defines itself as a Python object of the native type without being so. So it may quack as a duck, but not being a duck. And this type checking may be particularly true for advanced and uncontrolled input or measurement situations, but is uncommon for controlled input or data situations. So when you have your data set in a comma-separated file and everything is proper, and you have these textbooks data set, this may never be a problem. But when you use measurement systems in nature or on humans or whatever, you may get these input or output troubles. And the worst data usually comes from the internet. because when you have some random users sending you data on the internet, either through a web interface or something, you don't really know what sort of data you will actually get. And this can be valuable knowledge for real-time data analysis within internet applications, for example. So right, this description shows the most important properties of the list. The list's flexibility and the need to control the list and its objects either at input time or at output time, or perhaps at both the input time and the output time. So the technical properties of the list are that list items are indexed with integer numbers and that the first item in a list always has the index number 0, the second 1, the third 2, and so on. Lists has the advantage that we can address a position in the list by referring to an integer number. And Python creates lists through items separated by commas within brackets. And now we're going to take a look at some example code. So start up your code editors because we're going to type some Python list code. All right, having started our code editors, we will type some Python list code. And we will start to type Python list. And we will create a first list. We type list1 equals integer 7, 4, 3, 9, and the string bananas. We can print the type of list1. And we can print list1. So let's run this code. And here we can see that we have a list. And we can see that this list consists of the integers 7, 4, 3, 9, and the string bananas. We can show how to address list objects using the object's position inside the list. We can type print string list1 3 plus string list 1 plus some white space plus string list1 4. And we can type that string list index instructs Python to print the content at position index as a string. And we can say that this is one way to control the output from a list. And this is a flawed way to control the output from a list, but it is effective and it will work for most native Python objects. So let's run this code. And here we can see that we have the output 93 bananas. Now we will operate on list objects using the list notation. We will print type of list 1. And we will print the type of the string of list 1 at position 3. So let's run this code. And here we can see that the object at position 3 is an integer. And here we can see that we have cast this integer as a string. And we can continue and we can say that a list object content may be changed by assignment. We can type list2 equals 2. And we can print list1. And we can say that this will print 7, 4, 2, 9 bananas. So let's run this code. And we can say that new objects can be added to a list with the append method. We can type that we want to append apples. And we can print list1. So let's run this code. And here we can see that we have added apples to the last part of this list. And we can say that we can remove objects from a list using the delete statement or the remove method. We can type delete list1 element 4 and we can print list1 and this will remove the bananas. So let's run this code. And here you can see that list element 4 was removed from the list. And we can also use the remove instruction. So we can type list 1, remove apples. And we can print list 1. And this will remove the apples. So let's run this code. And here we can see that the apples has been removed. And we can say that Python lists can be added together using inter alia, the plus operator, or the extend or append methods. So now we will create a list 2 and a list 3. We type list 2 equals 1, 4, 5, 6, and 8. And we can create list 3 as list 1 plus list 2. And we can print list 3. So let's run this code. And here we can see that list 1 and list 2 has been added together. And we can use the append method, so we can type list 1 append list 3. And we can print list 1. So let's run this code. And here we can see that list 1 has had list 3 appended at the fourth position as a nested list. And we can type list 3 extend list 2. And we can print list 3. So let's run this code. Here we can see that we have list 3 extended by list 2. And now we will show some properties of the list. For example, how you count the number of objects inside the list, or you could say the number of active object positions. So we will print the length of list 3. And we will print the length of list 1. So let's run this code. And here we can see that list 3 has indeed 14 positions. 4, 6, 8, 10, 12, and 14. And we can see that list 1 only has 5 positions. So here we have the first 4, and this entire list counts as 1 position. So how many elements you get from the length instruction depends on whether you have list brackets for this list at a position, or if you, for example, extends with the content instead of the entire list. So using the append or extend instruction results in different results. And this is something to keep in mind and something to think about when considering lists, and in particular lists of lists. But let's save the list of lists or multidimensional lists for last. So now we will learn to sort list 3. So we will print list 3, and we will sort this list. And we will print list 3 after it has been sorted. So let's run this code. And here we can see list 3 unsorted, and we can see list 3 sorted. And this sort instruction will sort these integers based on the value of the integers in the list. And you can sort them both ascending and descending. And sorting lists are often important within data handling. So right, now we'll address ranges of the list. We can print list 1 to 4. And this will give us in the case of list 3, 1, 2, and 4. Like this. And we can print list 3. And this will give us 1, 1, 2. Everything to the left of element 3, which is 4 in this case. And we can print list 3. And this will give us 8 and 9. What we say here is that everything to the right of element 12, and you know that it is 14 elements here. So this is 14, 13, and this is number 12. So all right, let's run this code. And here we can see that we have a list consisting of 1, 2, and 4, 1, 1, and 2, and 8 and 9. And as you can see, this is very useful because here we can point at the number of positions in a list. We can print them, or we can make operations on them. And we will look a bit more at this when we look at multidimensional or list of lists in the final advanced section of this video. Now we will take a look at how to loop a list using for loops. And this is very simple. So we just type for x in list 3, print x. And let's run this code. And here you can see 1, 1, 2, 4, 8, 9. So here we have looped the list and we have printed the list. And now we'll take a look at moving objects from one list to another list. And this is often very important both in data handling and in, for example, algorithms. So you want to move, for example, one object after operation to another list, and so on. We can begin by printing list 1, and we can print list 3. And we can take list 3 and we can append list 1, pop 1. And we will print list 1 and we will print list 3. So let's run this code. And here we can see that from list 1, we have the object at position 1, which is a 4. And that has been moved to the last position of list 3. So this 4 has been moved here. And here we can see that the 4 has disappeared. And we can see that the 4 has been added to this list. And we can move objects from one list to a specified position in another list. We can type print list 1 and we can print list 3, and from list 3 we can insert at position 2 list 1 the first item. And we can print list 1 after operation, and we can print list 3 after the operation. So let's run this code. And here we can see that object 7 has been injected into position 2 on list 3. And we can also see that integer 7 has disappeared from list 1. So right, now we're going to look at advanced list functions and such things. So if you feel that this part of the video lecture becomes a bit advanced, just continue to the next video and return to this video later. For example, when you have made one pass through this section on Python, you can return here, and for every repetition of this video, you will grow better and more competent. And this should be quite simple, even if you are a rookie after 1 or 2 passes. So right, now we will take a look at type checking using the type and is instance methods, or you could say functions. And we can say that object type checking may be straightforward when all data is molded into a Python compatible form or a Python form. And we can say that this is not always true. For example, when sent unknown data over the internet, or if you're using analog or digital measurement systems. And we can say that type checking can very quickly become very advanced. So what we will do now is that we will show some basic functions for type checking, assuming a list of integers, or the intention to have a, you could say, a list of integers. We can type string test 1 equals 1 and string test 2 equals 1. So here we have 2 named strings. One is a string and one is an integer. And we will append them at list 3. And we will print list 3. So let's run this code. And here we can see that we have a list of integers, but that we have a string concealed as an integer inside this list. And in this version of this video, we will not add a bug to this type of type checking, but we want to make it known, or make you understand that type checking is very advanced and that it can fail even when it looks foolproof and you have covered all possible types of objects. And this is in particular true for internet data, but also happens with measurement data. So right, let's type for x in list 3 if type x is not int, print not integer. Else print integer. And we can type for x in list 3 if instance of x is an int, print integer. Else print not integer. And here we will add some white space. So let's run this code. And here we can see that in both these cases, both these methods managed to identify this string as a not integer. And this is a textbook way of showing type checking. And when you add custom objects or, for example, custom objects that can overlap with Python's native classes, such as, for example, ints and strings, then this quickly becomes very advanced. So right, now we'll take a look at multi-level lists. Also called list of lists or multidimensional lists. So what we'll do now is that we will create a list 4, which is equal to 1, 3, and 5. We will make a list 5, which is equal to 2, 4, and 6. And we'll make a list 6, which is equal to 3, 5, and 7. And we will make a list 7, which is equal to list 4, list 5, and list 6. And we will play around a little with these lists. So we will print list 7. And let's run this code. And here we can see that the list 7 at its first position has this list. At the second position, it has list 5. and so on. So what we'll do now is that we will show how to address multi-level lists. So we will print list 7, first element, and we will use the brackets to print the second element of this list. So let's run this code. And here we can see that first we identified this first list, and the second number inside the bracket identified this object inside the nested list. Now we'll play some more. So we will type list 4, extend list 5. And we'll print list 7. And this result may shock you a little bit. So let's run this code. And here you can see that list 7 and list 4 are nested objects and not separate objects. And persons who have experienced with older static programming languages might find this a bit surprising, because they intuitively want to believe that this instruction will create an entirely new copy, whereas in Python it does not. So here we can see that list 4 has indeed been extended, and as list 4 is a part of list 7, the object inside list 7 has been extended. And we can take this further. So we can extend the second level nested list with a third level list. So we can type list 5, extend list 1, and we can print list 7. So here we have list 5, and it will be extended by list 1. And list 1 we have here. So let's run this code. And here we can see that list 1 is now a part of, you could say, list 5. And it also brought its string with it. What we will do now is that we will show you how to access third level objects. We type print list 7, 1, 5, and 2. And this will point at this object first. And 5 will point at this part of the object, the third level. And 2 will point at this number. So let's run this code. And here you can see that it printed the integer 7. And now we'll show you how to access third level objects with a for loop. We type for x in list 7. Print x. And as you can see, we use the same part of this nested list. So here we point at this object and we point at position 5, which is this nested list. And now we'll print it using a for loop and a print instruction. So let's run this code. 1172 and so on. And when we print this, they all appear as strings, regardless if they are integers or strings. And this list notation, where we point at the position in the lists and the number of lists which you can nest inside other lists, are only limited by your ability to type finite numbers. However, it must be said that these multidimensional lists become very unwieldy quickly. So it's considered Pythonic to not use more than at maximum 3 nested lists, and preferably use as few nested lists as possible, because it can quickly become very hard to read and understand. And most brilliant people can only visualize in their brain volumes. They can see 3 dimensions, but they can't see 4, 5, 6, 8, or 9, or even more, which could be worse. But most brilliant people can see 3 dimensions. And most educated persons can see 2 dimensions. But almost everyone can see 1 dimension. And this is a great reason to limit the number of dimensions when you have the option and creates this code. Because one day someone else might be using your code. And then it can be advantageous if that person can read and understand the code. So this was some words of wisdom about what is Pythonic and what is not Pythonic in the perspective of Python lists. So right, this has been an exciting video lecture about Python lists, and now you know how to use and handle Python lists for data handling and also applications. You have had a great, possibly one of the best introductions to the very useful Python lists available. And in the future videos, we'll teach you even more. And we look forward to see you in the next video.